These are interesting sections, especially 8-7. We're going to do some word problems today. I like word problems. I don't know about you, but I like to see where math fits in the real world. All right, so before we can get there, we got to do 8-6, and then we'll get to 8-7, which is all real life, which I enjoy. All right, 3x squared times 3x, let me write it a little bigger here. 3x squared times 3 to the 3x. We're getting advanced here. This is no longer intermediate algebra. We're kind of edging into advanced algebra. This is like what a pre-calculus student would do a lot, these kind of things. All right, so pretty advanced problem here. You got x up in the power zone. What do you do when x climbs up there into the power zone? Exactly. You try to make the bases the same. Exactly. That's the first. If you can't do that, what do you just give up? No. If you cannot, you do ln of both sides. And then bring power down front. Okay, that's if you cannot. We'll get to some of those in a minute. But this one I can make the bases all the same. How can I? 9 is 3 squared, right?
No.
And there's 3's over here. 9 is 3 squared, but it's actually 1/9. So what do I do with what's going to make it become 1? If I just leave it 3 squared, that's not right because that'd be 9. This is actually 1/9. So what makes it 1/9? Negative 2 on the power. Remember when the power is negative, that's what makes it do the flip thing? So 3 to the negative 2 on that. We good on that side? So when you see the 9, just think, okay, 3 squared, and then what's going to flip it? Oh, negative 2. Negative powers flip things, right? Getting more and more comfortable with that reality. Okay, now the other side, I want to make it 1, 3, not 2 of them, just 1 of them. And what's the power going to be?
4 something.
Okay, what's the rule? So you know what I do in this kind of situation? Because it's hard to remember all the math rules, right? There's too many stinking rules, aren't there? There's so many rules. You don't have to have them all perfectly memorized. You really don't. I would have never made it if you had to. But what you can do is test it out. What I mean test it out? When I look at something like this, I would think, I don't remember. What do you do with those things? Add them, multiply them, something like that. I would just think, okay, well, wait a minute. What would I do with like 3 to the second times 3 to the third? So I would just make a simpler case of the same thing. What is that?
3 to the 5.
3 to the 5 is correct, right? Because this is 2 3's and this is 3 3's. So there's 5 of them. So what do you do with those powers then? What's the rule? Add the powers, huh? See, I don't know if you guys ever do that, but that will help you a lot. Just when you're trying to look at some hard situation, try to make it simpler where you might remember the rule and then do the same rule in the harder case. So that means I got to take these powers and I got to add them. So x squared plus 3x. Now they can't add, you can't, because they're unlike terms. They're just going to stay separate. But they still made 1 3, not 2 3's. Does that make sense what I did there? The 2 different 3's combined into 1, add the powers. And that's as much as we can add the powers for now. Good so far. Now that the 2 bases have been made the same, try to make the bases the same. We did. We got 1 3 on this side, 1 3 on that side. Now that the bases are the same, what do we do from here?
Yeah, you gotta
set these powers equal, huh? You were assuming that, huh? Yeah. X squared plus 3x is negative 2, right? Once the bases are the same, you're free to set the powers equal. Do you remember that? Why? Well, because if 3 to something is equaling 3 to something, those somethings, those powers, must be equal, or 3 to one of them wouldn't equal 3 to the other if they were different, right? Does that make sense? If I say, hey guys, I'm thinking of some power, 3 to that power is coming out the same as 3 to this other power. Well, those powers have to be the same, or 3 to one of them wouldn't equal 3 to the other if they were different, right? So we know the powers are equal, so once you make the bases the same, you can really just drop the bases out, and you know the powers are equal. Now it's come down to solving that.
get a 0.
Good job. So once we see x squared, the game plan is always get a 0.
Oh.
Question, Ajane, we good to there?
Yeah, no.
Let's drop those bases out. And Move that one over there like that. So it becomes a plus 2 equals 0, right when the negative 2 jumps over. Then the whole factor thing. What multiplies to be 2 and adds to be 3? Yeah, 2 times 1, everybody's positive here, right? Multiplies to be 2, adds to be 3 in the middle. And so then you know it's just opposite sign, huh? So it's negative 2, negative 1. There's the two answers, and we are done. Don't need to check them or anything like that. Questions I can answer on that one? All is good?
I'm sorry, where did you get the 3 to the negative 2 power?
Oh, yeah, no, that's a good question. That's one of the trickier steps. That so I looked at the 9, and I said, well, that's 3 squared. But I thought, yeah, but it's 1/9. How do you get that 9 to flip to the bottom? Make the power negative. Yeah, negative powers is what makes it a 1/9 instead of a 9. Good. Other questions on that one? Good with all those steps. So when we see these, there's so much on the next test and it can be kind of hard. This one also is at the level of difficulty of exam 4. 4 and 5 are the two hardest exams by far in this class. You can see why the material's hard. How are you going to recognize this with all the stuff we're doing? Well, x in power. That's the key. When x is in power, you try to make the bases the same, and if you can't, then you do the ln on both sides. So you want to have that game plan on your 3x5 card. When you have x in power, try to make the bases the same. If you cannot, then do the ln of both sides. That's the game plan whenever x climbs up here into the power zone, right? Is that good? That's the key mark. That's what will distinguish this from everything else we've done. So we have 8 to the x equals 16. So do you see how x has climbed up into the power zone? Climbed up there into the power zone. So when you see x in the power, you should try to make those bases the same. Now, can I make that 16 is that 8 to the second like that? 2 times 8, 16? No, that'd be 64. That'd be 8 times 8. So that's not going to work. What's going on here? We could do the ln thing, but there is a lower base you can make them both out of. 2. Make them both out of 2. Right? 8 is 2 to what power? 2 times 2 is 4 times 2 is 8. 3 2's, right? And the x is still up there. And 2 to what power is 16? Use your calculator if you're not sure. So you can. This is a case where you can make them both out of a smaller power. Mm-hmm. So see how I was able to make the bases the same? So sometimes you got to change both bases, huh? Not just one of them. So I wanted you to see this example. And then what do we do once we make the bases the same like that? And just cut out the bases, because 3x must equal 4, right? The powers must be equal. So then how do we solve for x? Divide by 3. X is 4/3. Do you have a different plan, Ajane? No? 4/3. We all good on that one?
Oh, if you do the ln thing, it still comes up the same.
It does. It'll work that way too. No questions? All good? Okay. So this is all about, again, when will you recognize to do this on the next exam? When x is in power. Right? It's all about x climbing up there into the power zone. That's what we have to do, this fancy stuff. Okay. So I've got
This one had me stumped.
e to the t is 305. Okay. How are you going to recognize this on the next exam as something? What's special? What's the unique mark? The letter, the T we're trying to see. They want to know T in the end. That's my variable, what I got to solve for. It's in power. Everybody getting me on that? I'm trying to do something that'll... So I know that's what's hard. You take a test. You've done all the homework. You take a test, and they all kind of look alike. So I'm trying to really help this stand out for you. When the letter climbs into the power zone, right? That's the bad thing. All right. So when the letter climbs into the power zone, it's up there. It's raised up in the power. In other words, it's not just like T to the 5th power or something. I mean, that'd be hard too, but that T would not be in power in that case, right? See the difference I'm talking about? I'm talking about not just that it has powers, but that the letter itself has climbed into that power zone, right? Everybody with me on that? All right. So what do you do when the letter itself has climbed into the power zone? Well, you try to make the bases the same. No way. You get that weird E thing? No way we're going to make the bases the same, right? So let me write this. So try to make the bases the same, but no way in this case. So then what's the other choice? ln both sides, power down to the front, huh? So I go ln on this side, ln on that side. Everybody good? And then the reason that we're... Wait, so I don't want to go too quick. We're good on that. So ln, when you can't make the bases the same, no way we can do it because of that weird E thing. Do the ln on both sides. And then why do we do that? Well, because remember the log properties that we went over last time? Powers come down to the front. See, the whole problem is that letter's up in the power zone, and we don't want it there. So we got to get it to come down. And that's the great quality of the log, is that it lets those powers come down to the front. Is that good to there? And what's the ln of E?
How do you even do that?
Let me just tell you, it's 1. Whenever you've got ln E, they're opposites of each other, is what they are. Yeah, let's just leave it at that for now. I'll explain more later. So they just cancel out, and they're just 1. So we just have T equals ln 305. All right, everybody see what happened on the left side? ln of E just cancels, it's 1. So ln 305, and they want a decimal. So you guys have your calculator. What is ln of 305?
5.7203.
7203. It says 4 places. Yeah, is that rounded correctly to 4?
Yes.
Is that good? We getting that in the calculators? Is that right? Is that good? Questions I can answer on that one? So ln both sides, when the letter's in power, ln both sides, power comes down to the front. And ln of E is just 1. Why is ln E 1? Remember, every log has a base. If I write log 12 or whatever and I don't show the base, what base is really understood to be there?
10.
Yeah, there's 10 if nothing's shown. Now, if I write ln 12 or whatever and I don't show a base, what base is that one understood to have? E. Yeah, that's the other understood base. This one's called the common log. It has base 10. This one's called the natural log. Remember, it's the word backwards. It's logarithmic natural. The L and the N are French.
Yeah.
They put the adjective after like in Spanish where they say the car blue instead of the blue car. Right? That's the way French is. The logarithmic natural. Natural is the adjective describing logarithm. So you reverse it. It's natural log. And natural means the base is the naturally occurring number, E. E is a special number like pi. If you go up to calculus, you'll see what it is.
Just like log base B of B is 1.
Right,
Yeah.
right. And so, yeah, so that's right. So therefore, if you take ln and you put E like that on the level, see, that E's not the base. That's not lowered down, right? That's on the level, like the 12 is. That's like in the place of the 12, right? Which means there's also another E right there.
That's also 1.
That's why it's 1. Because remember when these guys match, it's always 1. Remember how we talked about that? because that means the log of the top one over the log of the bottom. Remember, you could turn that into two logs. Log of the top one over log of the bottom one, which has got to be 1. Make sense? So that's why the ln of e is 1, because that's the base matching the plug-in. And that always makes a log 1 when you do that. Like log base 7 of 7 is 1, or log base 3 of 3 is 1. The same way ln of e is 1 because there's another e there. Good? So that's why. All right. Yeah. So e to the minus t is 0.91. So ln of both sides, right? Ln, because the letters climbed into power. Ln of both sides. So this power comes down to the front like that. Good, so that's the special third property of logs. Powers come down to the front. And then ln of e, as we talked about, is just 1. So this is negative t is ln of 0.91. Good so far? Now we want to get regular t. So what do I do to turn that into regular t? Yeah, divide by negative 1 on both sides. That'll get rid of that. So then hit the buttons on your calculator. ln is 0.91 divided by negative 1. It's going to be positive in the end, isn't it? What does it come out to be?
0.0943.
What is it again?
0.0943.
0.0943. Is that good? Thank you. Questions on that one? Is it good? No questions? All right. I'm looking for, you guys don't look thrilled about that one. All right. So we've got e to the minus 0.96t equals 0.62. So try that one. Same thing. ln both sides, right? Okay, ln both sides. And then the whole power comes down. Oops. Like that. ln e is 1, like usual. We good to there? And now we just divide by negative 0.996. On both sides. So t equals, somebody got that? ln 0.62 divided by negative 0.96. Nobody's got an answer?
Is it 0.497?
4 point.
I think it'd be 4980. 0.498.
It's 79 and then 5.
Oh, 795?
Yeah.
Yeah, so 795. Yeah, right, because you remember what you're supposed to do, they want you to go 4 places. So you circle the 4th place, look 1 to the right. If the 1 to the right of the 4th place is 5 or more, you got to go up. So when you round 79 up, it goes to 80, right? 0.4980. Good. Is that okay? Questions on that? When the letter climbs into power, right? It's not just with the E thing. That's what I don't want you to get confused. I'm hoping they'll give me one without an E here. It's not just because of the E. It's anytime the letter's in the power zone.
Other than X.
What's that?
Other than X.
Other than X?
X, yeah.
No, X can be in the power zone.
Oh.
Yeah. Whatever the letter is.
Okay.
Whatever the letters, whether it's T or X or whatever it is, if it climbs into power, then yeah. So I'm saying the E doesn't make, because I think there's been so many that have had the E, a person could start to think, oh, it's whenever you see that E thing. No, the E doesn't have to be there. That's not the rule. It's because the letter has climbed into the power zone, the variable.
Is that when there's a negative in the power?
What's that?
A negative in the power?
Negative or positive, either way. Yeah, because we had one a minute ago, didn't we, that had a positive? Yeah, see this first one here? That was a positive T in the power. And we still did the ln thing. It doesn't have to be negative. Okay. Yes, you see that? It's 7.2 to the x is 19. There's no e, but it's still L in both sides. It's the same thing, L in both sides, yeah.
Because you can't make the bases the same?
Yeah, right, because you can't, there's no way to make 7.2 and 19 the same base, exactly, yeah. Exactly, so when x climbs into power, right, that's when you gotta do L in. So go ahead and give it a try, same kind of thing. L in both sides. And then that x power drops down to the front. As you know, that's the third property of the logs, that powers come down to the front. And now how do we finish solving for x? Just divide by that whole ln 7.2 thing, right?
They didn't like it.
Divide by ln 7.2, divide by ln 7.2, boom. X equals. So type that into your calculator. Make sure when you type it in, though, let me show how to type that in. Whoops, put that over here. Make sure you go ln 19, close those parentheses, and divide by ln 7.2. So, it's going to be 1 point something. 4915. 1.4915. Is that good? You able to get that one? Does that make sense? Feel like you'll be able to remember that on the test? Because it's kind of hard to remember because because the ln is like not there at all, and you just got to remember to do it. You know what I mean? That's why it tricks a lot of people.
I'll be able to remember it when I have my 3x5 card.
Yeah, put that on your 3x5 card for sure. When x climbs into power. So I'm a wannabe history teacher, and this is a good moment in time where I just noticed over the years as I've graded this, people People just see this and they don't know what to do because the ln's not there and you got to kind of remember it. And they just don't recognize that that's a big deal when x is in the power zone. That's why we need to do the big deal of the ln. So, all right, let me do the most famous case, I think. Hitler climbed into power, right? That was a big deal when Hitler climbed into power in Germany. I'm listening to Winston Churchill's biography, I'm going to mention, as I drive around. So we just finished World War II. And so anyway, Hitler wasn't in power at the end of World War II, as you know quite well. He was out of power. But how did he climb into power? How did Hitler gain power in Germany? Let me do a 1 minute of history here. Did the German people vote him into power? He lost the national election. Do you know that? It's kind of interesting. I think history is very interesting. Hitler ran for president and lost miserably. He lost. The German people did not vote him in. Somebody else beat him out. But he was given, that person that won the election appointed Hitler the chancellor, which was a nothing compared to president position. It was much lower than president at that time. So Hitler did not win the election. This other person did in their 30s, early 30s. And then there started being what was called the Red Scare. They were scared of the communists, and things around Germany started blowing up. They said the communists were doing it, the Russians. There's rumors that it was really Hitler's Nazi party that was doing it to produce a scare in Germany. For whatever reason, things were blowing up around Germany, and the people got scared of the Communist Party. And so Hitler, as chancellor, was able to get legislation passed, which gave him military wartime powers, right? Special powers just because we're under threat right now. Things are blowing up around Germany. We got to give the chancellor some special powers. And he got enough paperwork through because everybody was scared to give him more power than the president just during the scare. And somehow the scare never ended. And he became supreme in control. He never won the election. He was just politically savvy and scared everybody and got the power. All right. Let me say one other thing. This is one of my favorite scenes from scenes. I'm listening to Churchill's biography. You know Churchill, right? He made war on Hitler. He's the one who says we will never, 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 never surrender, right? He was the leader of England through World War II, really the leader of the Allies. And they did. They won. He took pleasure at this one point when they finally beat back Germany enough to where the British forces and the Russian forces and American forces were in Germany, and they took control of one of the German rivers, the Rhine, I think it was the Rhine, one of the rivers that's in Germany. We had German territory at this point. It was like 1944, near the end of the war. Churchill flew over there with his plane, got off the plane, and went over by the river that now England controlled and relieved himself in Hitler's river. And he took great pleasure. Said he was like a schoolboy, that he got to go to the bathroom in Hitler's river saying, "We gotcha." Anyway, funny scene from history, I think. Why did I do all that? What am I trying to help you remember? It's not just that there is an X, but that it climbed into power, right? There's always cuckoos that have Hitler's view. There's people right now that have those views, right? That we should wipe out the Jews and all the racial weird stuff, right? But they're not in power. Well, hopefully. But anyway, so, right, I mean, yeah, well, we'll set that aside. But, I mean, like in supreme control, right? That's the problem. So I'm trying to help you remember. When you see this on the exam, think of the Hitler. I mean, Stalin was worse. Anyway, I won't go into Stalin. He was in power in Russia. He was worse than Hitler. Anyway, so when the wrong person gets in power, so when X is in power, that's the deal. That's when you got to do ln to both sides. I'm trying to help that really sink in. It's that the X climbed into power that's the big deal. Abraham, do you want to say something?
Oh, no.
Oh, okay. Did I not? Let me go back and take a look.
The ln turned into negative 0.96.
Let's see. Which one was it?
Because ln cancels out.
13. This one? Oh, yeah, this one right here? This one?
12, yeah, that one has ln on top and bottom.
Okay.
12, you didn't do that.
Towards into that.
So what's the difference?
Because ln turns into 1.
Oh, yeah. Good question, Carr. Yeah, Carr's question's good. Look at number 12 there. Yeah, right here, the other ln was of E. And ln and E, that's what made that ln cancel out and just become 1. Yeah, so when the ln is on an E, it just disappears. It just cancels. Whereas, like, if it's on anything else, like here it's on a 7.2, it's not going to cancel. Good question. Only with the E does it cancel. Okay. So where are we? Right here. All right, so let's try this one now. Okay. So when do we do the whole ln thing on both sides? When Hitler climbs into power. When the X climbs into power, right? That's when you're in trouble.
Yeah.
Right. All right. Yeah, I hope you remember that. All right, so here we go. So log base 4 of x equals 3. So how do we solve this thing here? We had a lot of log stuff, huh? So this isn't ln time, right? Because x is not in power. Good. It's not one of those, right? We've changed gears. But it is a log. Just got a log, so we're going to do some log thing. What should we do? What did we learn about when we cross? Could we just cross off the log? Yeah, that's actually what we want to do. Remember what we learned when we cross off a log? Lose a log?
Gain
Base stays the base, other two switch. Let me write that again for you. Whenever you lose or gain a log, when you put a new lose or gain, either way, a log, lose or gain a log, the base stays the base, the other two switch. Whenever you gain or lose a log word, the base stays the base, the other two switch. So 4 will continue to be the base, right? The low down one. The base means the low down one. And the other two will switch. So instead of 4 to the x power, it's 4 to the third, and the x goes over there. Let me slow down there for just a second. So everybody see what happened. I lost the log word, right? It vanished. It's not there anymore. And whenever that happens, whenever you lose a log, the base stays the base, the other two switch. Yeah, and then just use your calculator, totally. 4 to the third just means 4 times 4 times 4. That's just 64, and we're done.
Oh, that was easy.
Is that good? So you see how it had nothing to do with ln because x wasn't in power. Hitler didn't climb into power kind of thing, right? That had nothing to do with x in power. So you won't confuse the techniques. This is totally different, right?
Right, so
Yeah.
will log and ln ever?
No, we'll never put them in the same problem. Yeah. Good? Okay. Log base 6 of x equals -4. So same kind of thing, just lose that log, right? Cross off that log.
Whoa.
So cross off the 6. The base stays the base. Yeah, cross off the log. Did I say 6? Yeah. Cross off the log. Cross off the log. Base stays the base. Other two switch. Instead of 6 to the x, it's 6 to the -4. Right? Because that looked like 6 to the x power. It's made to look that way. So when they switch, the -4 is the power of the 6. And the x goes over here. Good. When you cross off a log, base stays the base. Other two switch. Now, what do you do with that? What is a negative power?
Only one.
Flips it. Yeah, over 1, right? Really important on this test. And then the power becomes positive after the flip. Remember that? Really important. There'll be a lot of problems on this next test that test that. Negative powers do not put a negative in the front. Notice there's no negative in the front. They just flip things, don't they? And then just use your calculator. 6 times 6 times 6, whatever.
1296.
1296, thank you. 1 over 1296. Is that okay? So negative powers flip things. Negative powers are very different from negatives in the front or the base, aren't they? Questions on that? That good? I'll keep moving. Log x equals 1. I'll give you a minute on that. Try that. Yeah, good. That log seems to have no base. But every log really has a base. There's no such thing as a log without a base. So what is it when we can't see it? It's 10. There's really a 10 there, right? If they write the ln word, what base is really there? E. Natural log is E. If they write regular log, it's 10. Yeah, good. Okay, now do the regular. Lose the log, base stays the base, other two switch, right? So the base stays the base. These guys switch. Set of 10 to the x is 10 to the 1. X goes here. 10 to the 1. That's just 10. Done. X is 10. We good? Questions? So log x is -5. So what's the base really? 10. Lose the log. Base stays the base. Other two switch. Set of 10 to the x. It's 10 to the -5. X goes over there. And what's a negative power do? Everybody good so far? Now what's a negative power do? Flips it. So this is 1. And then the power becomes positive after the flip. 10 to the 5th, that just means 5 zeros.
1/100,000.
Yep. 1/100,000. And there we go. Is that good? Questions on that? So
Good.
ln x equals 8. Solve for x. Yeah, it's not multiplied. So ln's another, yeah, good question. A lot of people, you feel that way, that can we just multiply by the ln? But no, whenever you want to lose any kind of log, you got to lose the log, base stays the base, other two switch. You have to do that special, you can't just divide by log or ln, in other words. Why not? Well, it's not multiplication. That doesn't mean ln times x. It really means ln of x, like a function. It's like me saying f of x is 10 or whatever. You can't divide by the f. The f's a function. It's like plugged into the toaster. It's not multiplication. It's not times. So anyway, that means you can't just divide. So what do you do then? This is another type of log. ln is just a specific kind of log. There's no base there.
It's E.
It's E, exactly. That's the other understood base. Everybody tracking with me? There's two understood bases, regular log base 10 and ln base E, when the base is not showing. So when the base is not showing, the regular log word has a 10, the ln word, natural log, logarithmic natural, base E. It's base E. So then the rest is normal. What do I mean normal? I mean, what do you do with a log? Cross it off. ln's just it's just a log with a base of E.
You still flip the x.
Yeah, still flip. All the rest of that is regular. So lose the log, base stays the base, other two switch. E is the base, right? Set e to the x, it's e to the 8. X goes over here, we're done. That's all they want. They just want it that way, e to the 8. Is that okay? Does that make sense? So ln is always base E, regular log is base 10 if no base is shown. Then just cross off the log, any kind of log, even a natural log. Base is the base, other two switch. All right, so log base 3 of 2x minus 3 is 2. All right, you know the deal. Cross off the log, base stays the base, other two switch.
Are you setting this up?
No, this is a good one. No. Yeah, this one will work fine that way. So you cross off the log, base stays the base, 3, other two switch. Now, what about, you mean like all that stuff? Yep, all that whole 2x minus 3 switches places with the 2. So instead of 3 to the 2x minus 3, it's 3 to the 2, and the 2x minus 3 goes over there. Does that make sense? We good so far? And 3 to the 2 is 9. And now we just solve for x, huh? So just add 3 2x is 12 divided by 2. X is 6. And we're done. X is 6. Questions on that one? All right. Last part of this section, which is a little bit of work. So, okay, what do you do when you have two logs?
Don't you multiply them?
You make it one log by the properties. Remember those three properties we learned? I hope you finished that homework. That's how math is learned. You master it and you can ready for the next section. If you're fuzzy on those properties, this will be hard. Make one log by the properties. What properties? Meaning adding becomes multiply and subtraction becomes divide. Remember those properties we learned? So make it one log by those properties. Step 2, lose the log. And you know what that means. Base stays the base. Other two switch. So the base stays the base, the other two switch. And then step 3 is solve. Step 4 you must check, unfortunately, but it's an easy check. Check. How do we check? What are we talking about? Check. Plug answers into first step. No zero, no negative inside any log. So there's the steps. You want to get those down? Maybe I'll write them on the sideboard too. Okay. There we go. We're going to do it. We're going to keep using that process, like the next 8 problems. And another thing I can say to help you remember this, so I've got another story. No, I'm kidding. No more stories. But I'm just going to say lose the log. Or no, I said that already. Count down the logs. I'm forgetting my words here. So count down the logs. What do I mean? What I mean is on the first line you're going to have 2 logs. Next line you're going to have 1 log. Then you're going to have no log. That's how you kind of want to, that'll probably help you remember it. Just think it's a log countdown. 2 logs, 1 log, no log. That's how the flow will go. It's going to be 2 logs, count down the logs, 2 logs, 1 log, no log. All right, let's give it a try. What am I talking about? So, all right, so here we have log x plus log x minus 15 equals 2. All right, so notice on the first line we have 2 logs, right? So this hopefully on the test help key your memory. You go, okay, 2 logs. Oh yeah, count them down. So next line there should only be 1 log. How do we make 2 logs come together and become only 1 log? The properties. Adding becomes times for 1 log. Good so far? Everybody see what happened? See how it went 2 logs to 1 log? Right? Here I had 1, 2 logs. Now I've only got 1. By the properties. If that had been a minus in the middle, if that had been minus, then this would be x divided by x minus 15, wouldn't it? Remember, subtraction means divide. Remember, easy job for 2 logs, adding or subtracting, becomes a harder job for 1 log. Remember that my analogies I made for this? So subtracting for 2 logs would be dividing, right? Subtracting goes with dividing. They both make things smaller, subtracting, dividing. Adding goes with multiplying. They both make things bigger. So adding 2 logs means multiplying within 1 log. Okay, so 2 logs, 1 log, next line.
No log.
Supposed to be no log, right? So I think that'll help you remember the flow on a test. 2 logs, 1 log, no log. How do I get to no log? Well, you cross off the log, to get no log. And what happens when you lose a log? Base stays the base, other 2 switch, right? What is the base? I don't see any low down number.
10.
Must be 10, exactly. So 10, so the base stays the base, the other 2 switch. What other 2? Everything else, meaning all this x stuff and the 2 switch. Instead of 10 to all that x stuff, it's 10 to the 2. And all the x stuff goes over there. Good so far. Trying to get this stuff out of the way here. Everybody try. So we're out of the log woods now. So we're out of the woods. We're out of the logs now, right? Guys, good so far? Everybody track with me. So I went 2 logs, 1 log, no log. We're done with the logs. Now just solve it. What do I mean just solve it? Well, what's 10 squared? 10 times 10, 100. What do you do the other side? Just distribute. X squared minus 15x. How do we solve an x squared equation now? Get a 0. So grab that 100 and jump it over here. 0 is x squared minus 15x minus 100. Factor that thing. Use your calculator. We're saying what multiplies to be 100 and somehow adds to be minus 15. What comes what's 100? 20 and 5. 20 and 5. Sign in the middle. Sign on the bigger. Minus 20 plus 15 makes minus 15 in the middle. And multiplies to be negative 100. Bless you. We good to there? And then you know what happens. It's positive 20, negative 5, right? Opposite, opposite. Remember how to you solve with the parentheses to the answer, parentheses, answer, opposite. Now, last thing that you do have to check, as I wrote out, it's gone now, but I wrote it. Got to check. Now, it's a simple check. You can probably just do it with your eyeballs. You probably don't even need to write anything down. It's really simple. You just take the first answer. I'll write it so you can see it, but you can probably just look and see it. You put the 20 in right there and the 20 in right there into the original first step. And you just make sure, I don't know if you remember, but the inside of logs can never be 0 and can never be negative. You do it on your calculator, it's an error. So log of 20, well, that's okay. I don't care what the number is. I'm not going to hit the buttons. As long as it's not 0, not negative inside the log, it's good. So that's not 0, not negative. How about 20 minus 15? That'd be 5. That's not 0, not negative. Good. 20 is a good answer. How about the negative 5? Well, no, obviously not, huh? Negative 5 right there is negative. No way. So the answer is only the 20. The negative 5 is a false answer. So the only answer is 20. Does that make sense? Now, careful, don't mishear what I'm saying. I did not say every time you get a negative answer, throw it away. That's not what I said. For example, if I got x is positive 6, I would actually throw that one away also. Why? Why would I throw away positive 6? Because if you put positive 6 in right there, what's 6 minus 15? I don't know, but it's something negative. Remember? So it's not that the number itself can't be negative. It's when you plug it in, it can't make the inside of any log negative or 0. If it does, it's out. Right? Everybody hearing me correctly on that? So you can get negative answers sometimes. And sometimes you throw away positive answers. It just depends what they do when plugged into the inside of the log. You cannot make the inside of any log 0 or negative. That's an error, and so we throw it away. All right, shall we move on? Try one of these? All right, let's try 23 there. Can you read? Let me write it up here a little bigger. So log base 2 of x plus 3 plus log base 2 of x minus 3 equals 4. Okay, give it a go. So think countdown. 2 logs, 1 log, no log. So next line, you're supposed to make that into 1 log. Let's make those 2 into 1.
Uh,
2 logs, 1 log, no log. So 2 logs, 2 log base 2's going to become 1 log base 2. And what do I do with the x plus 3 and the x minus 3? Because it's adding in the middle, it becomes multiplying, right? A harder operation for 1 log times easier adding for 2. Everybody good there? If that had been minus in the middle, then I would divide these, x plus 3 over x minus 3, right? With only 1 log still, though. 2 logs become 1 log. And now, so it's 2 logs, 1 log, next line, no logs. So you want to be thinking on the test. 2 logs, 1 log, no log. So that means you got to cross this out, right? If you're going to have no log. So you know what happens. Base is base, other 2 switch. So the 2 is the base. The other 2 switch. All this x stuff in the 4 switch. So it's 2 to all that. Instead of 2 to all that x stuff, it's 2 to the 4. And all that x stuff goes to the other side. That good? No logs now. We went from 2 logs to 1 log to no logs. 2 to the 4th power, that's 16. Now you just solve it. Boom and a boom. What is that? X squared minus 3x, boom and a boom. Plus 3x minus 9. These guys cancel. 16 is x squared minus 9. We're good to there. You could just get the x squared alone and root it. There's no regular x here. You don't have to zero factor. Remember, if you just have, you could, it would work, but it'd be even quicker to say, look, I don't even have regular x here. I just can get this, I can just add the 9. That's 25, right? And then root it. What happens when you put a roof on the house? Up and down the ladder, plus or minus. So plus or minus 5. You guys remember all my goofy analogies, right? The ladder, the roof, Hitler, the log countdown. Bringing in everything I can for you. Plus or minus 5. Now, we got to check them, though. Probably the negative 5 is no good. If you put the negative 5 in right there, negative 5 plus 3, the inside of that log is negative. So no way. No way on the negative 5, right? So the answer is only x equals positive 5, regular 5. Because that one's good. If you put in the regular 5, he won't make anybody 0 or negative. 5 plus 3 is 8. 5 minus 3 is 2. Nobody's 0. Nobody's negative. So 5's okay, but the negative 5 was not okay. Usually, one of the 2 answers is bad. Not always, though. They can both be good. They can both be bad, and it's no solution. But usually it's 1 good, 1 bad from logs. And usually it's the lower one that's bad, but not always. Questions on that one? Is that making sense? 2 logs, 1 log, no log. Log base 4 of x plus 1. Minus log base 4 of x equals 4. Okay. Give that a try. 2 logs, 1 log, no logs. So let me jump in and help with the first step. So 2 logs, 1 log. And what are we going to do when we go to 1 log? What are we going to do with the x plus 1 and the x? Divide, right? X plus 1 over x. Everybody good to there? Right, because subtraction between 2 logs becomes dividing for 1 log. Remember, easy job for 2 logs, subtraction. Harder job for 1 log, divide.
You can solve it like a proportion, right? Put 4 over 1.
What's that?
Put 4 over 1 and just cross 1.
Yeah, good. Well, not over 1. First lose a log.
Over 4?
So what's the next step? Remember the flow. 2 logs, 1 log, no log. We got to go to no log first. So that means cross off the log. What happens when you cross off the log? Base stays the base, and this switch, don't they? Right? Instead of 4 to all that x stuff, it's 4 to the 4, and all that x stuff goes over there. Everybody good with that? See how that's 2 logs, 1 log, no log? Always. And then you should calculate 4 to the 4th is some big number. So it is, thank you. Okay, everybody good to there? Now, what do we do to solve that? Yeah, put the 256 over 1, go diagonal, diagonal, huh? Cross multiply?
Yeah.
That's right. Two 56x, 1 times x plus 1. Everybody good to there? I'm racing ahead of you? Good. X's on opposite sides. What do we do to solve when we have x's on opposite sides?
Get the x on 1.
Just get rid of one. Yeah, just subtract x, right? 1x on both sides. This is what? 255x. Last step. Divide by 255. There's x. X is 1 over 255? Maybe. We have to check it. It's actually cake. Let me show you. If you put into that slot 1 over 255 plus 1, what is it? I have no idea, but it's not negative. Something positive plus something positive. It's not 0. It's not negative. That's all I care about. And if you put it in right there, what is it? I don't know, but it's not 0. It's not, well, it's just itself. It's just 1 over 255. So it's good. It's a keeper. So it's really quick. You can just check that real quick. As long as it doesn't make the inside of any log 0 or negative, it's okay. Does that make sense? Let me run over that one again. So again, we had 2 logs from the beginning here. 2 logs became 1 log by the property, right? The subtraction becomes divide. If that had been a plus sign in the middle, it would have been x plus 1 times x. It would become multiply, right? Subtraction becomes divide, then lose the log. The base stays the base. Other 2 switch. Get to here. No log at all. Cross multiply and solve. Are we good? We're about done with these double loggers, I think. Maybe one more. Maybe I should go to the word problems. We good there? No questions? Last call? Are you happy about these? Very happy? Extremely happy?
What?
Yes, it is warm in here, isn't it? All right, so try that one. So 2 logs starts off log base 4. 2x minus 15 minus log base 4 of x minus 4 equals 1. So there you go. 2 logs, you know the deal. 1 log, no logs, right? So 2 logs become 1 log. What am I going to do? In that 1 log, this is subtraction, so it's going to become division, right? Subtraction becomes division. That good? 2 logs, 1 log. Then we lose the log. Base stays the base. Other two switch. So instead of 4 to all that x stuff, it's 4 to the 1. And all that x stuff goes over there. Good to there? I'm going to go dot, dot, dot. We got to get to the word problems. Rest is the same. Put 4 over 1, cross multiply, blah, 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 blah. Everybody good to there? 2 logs, 1 log, no log? Questions I can answer?